I hope you'll go along with this rather unusual setting and the fact that I remain seated when I get introduced, and the fact that I'm going to come to you mostly through this medium here for the rest of the show. And I should tell you that I'm backed up by quite a staff of people between here and Menlo Park, where Stanford Research is located, some 30 miles south of here. And if every one of us does our job well, it'll all go very interesting, I think. The research program that I'm going to describe to you is quickly characterizable by saying, if in your office you as an intellectual worker were supplied with a computer display backed up by a computer that was alive for you all day and was instantly responsive, instantly responsive to every action you had, how much value could you derive from that? Well, this basically characterizes what we've been pursuing for many years in what we call the Augmented Human Intellect Research Center at Stanford Research Institute. So look what else we can do in here. I've got this file that's structured. If I want to see what's in there, I can walk down the hierarchy levels and see, or return. But there's another thing I can do. There's a root I said I have here. So here, I'm afraid I'll need a different picture of the view. So here's what I drew with a picture drawing capability here. It's a slight map if I start from work, and here's the route I seem to have to go to pick up all the materials. And that's my plan for getting home tonight. But if I want to, I can say, the library, what am I supposed to pick up there? I can just point to that. And oh, I see, overdue books and all. Well, there was a statement there with that name on it. Go back. What am I supposed to pick up at the drugstore? I see, very interesting. All right. Market? Oh, I've already seen that. Produce and all like that. Gee, that's too much. Anyway, so we have this feature of structuring our material hierarchically, being able to move around it very well. When we get a hierarchy, such as I can show you here now, I can do things if I want to just say, I'd like to interchange produce and canned materials. Bingo. And they're all numbered rightly if I care to look. Interchanging them very quickly. Cans are going to get interchanged with produce. They do it and all gets renumbered. So I have ways of studying over, making different views, moving around, going to specified points, and modifying the structure. At the same time, I've seen that I have a repertoire of different entities, like character, knock off that character, replace the character, make that P. So I have entities of all sorts that I can say I want to do operations on, and this basic structure that I can move over and study and get about very quickly. So that is the essence now. That's the essence of the tool we have. There are a lot of details that I've left out for you. And now I'd like to stop a minute and just make sure you understand we're shifting from illustrative material to the real working stuff, in case you wouldn't recognize it otherwise. We've used this tool to do our daily work, and our system has been built, this time-sharing system, for about 6 months now. It's been working, and in that time we've gone from getting one console to getting about 6 working now, with 6 more due the rest of the spring. This is our 4th computer in which we've had this kind of a system, so we've learned a lot about the user features we want and how to be fairly skillful. But this next step about learning how, when you're faced with having this in your office all day, as I now do, in a very exciting sense, how do you put that to work for yourself? How do you organize your files? What kind of things do you do? So to get going on this, let's switch away from the tool we have here and talk about some of the general features of the program, some of the ways it's built, and get back a little later to the nature of our usage of it. So that program involves about 17 people together with the special laboratory facilities we have. It's sponsored by government agencies exclusively, ARPA, NASA, and RADC now, and in the past, AFOSR and ESD, and these were the people that first grub-staked us many years ago. And it's been a goal-oriented pursuit for many years, and I think we can just go off and get a quick little picture I sketched to show this is the staffing over the years from 1950 on, and it's had slightly bumpy history. During these years, there was only one of us. But I go back to where I was and say, let's continue on in this file. That link took me out to a different file, to a statement for that view, and I jump back to this file where I was, and now within this file I make a link to another to say, the HIRC is pursuing these goals. Basic goal, improve the effectiveness with which individuals and organizations work at intellectual tasks. What does their effectiveness involve then? Better solutions, faster solutions, solutions to more complex problems with better use of human capabilities. Really thinking about that. But a corollary goal is, besides improving the effectiveness, to develop a system-oriented discipline for designing the means by which greater effectiveness is achieved. That's very important to us. The approach for this should result in the system-oriented discipline. Let me just show you how I constructed this file. You notice underneath there was that and that. There was just a link hidden here that went back to this view with a slightly different view parameters. To give you that view. All right, there's another one hidden there. It says the general approach for us, empirical. We're pursuing this monstrous goal, monstrously difficult, by building and trying empirically. And we're approaching it evolutionary-wise because we feel that it's a whole system problem. You need to get a person in that environment working and looking at the many aspects of his working system that are involved in his effectiveness. That's many more things than just these computer-aided tools. In a large system like that, we need to do it evolutionary-wise because we can't be analytic enough about it at any one point to decide what best our next thing should be. We can only decide from here, as well as we can analyze it, where we can invest our next resources to get the most return at an increase of the effectiveness of the system we have. And this item down here is the term bootstrapping applied in a slightly new sense. We're applying that to our approach, where we're saying we need a research subject group to give them these tools, put them to work with them, study them, and improve them. We'll do that by making ourselves be the subject group and studying ourselves and making the tools so that they improve our ability to develop and study these kinds of systems and to produce, in the end, this kind of system discipline. So it's a struggle doing it that way, but it's beginning to pay off. And I've given you an overall picture about the program, and that's out of the way, and I can just move my marker down and say, let's save that version. So this tool, in pursuing those goals, one of our principal tools is this computer aid system. Let's talk about it as a system. There's a link sequence to jump in there too, where we talk about NLS, meaning online system, a very general term. It's going to be NLS for many, many years, an online system that will evolve. Right now we consider it to be primarily an instrument and a vehicle for helping humans to operate within the domain of complex information structures. Well, what do we mean by operate? Well, compose, study, modify is the place we started now. We know there are many other analytic things you could do, but we want to get around, study, and modify. And then to further information about what does complex structure mean. We're talking about a complex structure and emphasizing structure because we say, although the content represents your concepts, there's a structural relationship between that content entities that should represent the relationship between the concepts of human thought. All right, we never can do that very well with linear text. So inside the computer we can represent that quite well. In fact, we can represent information structures in a computer that would generally be far too complex for you to study directly. But NLS serves as a tool to roam over that navigate through a complex structure, be able to find your way and be navigating, move about it rapidly, and be able to see what you want to see at any given point. That's how we think of NLS as a tool. All right, these are all very important concepts to us because these, together with bootstrapping, have told us where to start. We start by building an instrument that we can sit at and work during our day to organize the kind of working information we need as a task force developing systems. We need to write our specifications, our plans, our programs, our users' guides, our documentation, our reports, and even our proposals. This device over here is unique to us, and we always have to justify and explain it. We'll do it in reverse order. We'll explain it first. It provides for you the one-hand equivalent of what you can do with a keyboard. There are 5 keys, and normally each finger sits on a key, and depressing any one key at a time produces a character. And any 2 keys at a time also. And in fact, any combination of depressing, of which there are 31 combinations, it'll offer you a character. If I hit W, it'll say delete word. The arrow moves back and forth to give me feedback. My tracking spot changes. That gives me feedback. Now it tells me, since it's an arrow that is armed, I can do something. We get a lot of feedback. Let me restore a view like this to show you. This is more normally the way we work with feedback up here. Where here I'm shown, it's not working. That's an echo register that normally gives you the last 6 characters that you use. Oops, not working. All right. The last 6 characters, and left shifts continuously, so you can look up at any time and see what have I just struck. And that's very good feedback. Here are characters that show me the different viewing parameters, view specs. They get large at times at which I can hit single strokes that change those view parameters. And each of those means something to me, and their being large at particular times tells me I can hit very quick abbreviation for changing the view. So I can say, all right, I'd like to go to produce, but I'd like to go to produce, they get big, I'd like to say 1 branch only, and let me look just that low, and I see it. Oh, I can say, I'd like to see 1 line only. I can see it. So these ways I move around, the way I get feedback up here, the way I use both hands to coordinate to tell the computer what command and what short literals I want, are all carefully designed to go together to make the repertoire We've talked about the devices and now the nature of the dialogue, or the kind of feedback we get from the computer for each of the discrete character strokes and actions that the user goes through when he's executing a command. So that system is really represented to a user by the repertoire of commands he has, by the function of each of those commands, and by the control dialogue he has for each of them. So they all together go in and making a design, and to do it well you have to be very careful about the nature of the functions in that repertoire and the natures of the way they're controlled. So we've developed a very special language for talking with extreme precision about these control, both the command functions and the control dialogue for them. And a little bit later, when we tell you about the programming, Jeff Rulison will bring in some special examples to you of the languages we've used actually to program at high level these functions and the control feedback that we get in these control dialogue. I'd like to link to Bill, and I don't know what his terminal is right now, so I have to ask for somebody to connect me to him audibly. So Bill, will you come in through this intercom?
Hello, Doug.
Hi. I need to know what terminal you're on, Bill.
13.
Okay. I'd like to have him see my text. And so this special thing, if I label 13, will switch over, so in his display he sees my text, so I'll execute it, and sure enough it does. But what's that running around? Well, if he's looking at my text, he'd like to have something to say about it. So we put on a marker, a tracking spot that he controls. So he's sitting in Menlo Park looking at this text, and he can point to it. But we've carefully reserved for me the right to control and operate on this, so my bug is more powerful than yours. But we can have an argument. Yeah. That's what they call a bug fight. So, all right. So in case you haven't been listening, Bill, we've been going through lots of examples and setting up in collaboration here so that we can go on into information retrieval. And we've set up now audio coupling, and then we're both looking at the same display, and that'd be very handy to work. We can talk to each other and point, and maybe later I can hand you the chalk on this blackboard, like saying, here, you control it. But let's stay this mode now and add another feature that hardware-wise is available to the kind of display we have. I'd like to see you while I'm working on it. So before I can do that, I have to set up my display in a certain way. Set it up so I see it over like that. That leaves a corner up there, and I say, now computer, do the automatic switching that'll bring in a camera picture from the camera mounted on his console, such as the camera mounted on mine is. Hi, Bill. That's great. Now we're connected audio. You can see my words, you can point at it, and I can see your face, and we can talk. So let's do some collaborating. You're silent. Oh.
What do you want me to say?
Yeah. There's nobody here but a large audience, Bill.
All right.
All right. So let's go talk about information retrieval. And there are a lot of things I've been showing them and jumping around and finding your way, relating back to the portrayal I gave about NLS as an instrument on complex data structures. It shows them how we can get around and find things. I showed them the content analyzers to help locate things locally. You had a file kind of classifying retrieval stuff. Why don't we switch to it?
By the use of a hierarchy here, I mean working down through the hierarchical structure of the file, making use of the categorization that's built into the file. This we've seen several times. Let's, just as another example to really make this clear, we've talked about the desire to get hard copy of a file, wanting to get something printed out. There's quite a large system that takes care of giving of making a file for hard copy. You're able to specify how you want the hard copy to look by giving various directives. One of the things you might want would be Roman numeral page numbers. So let's go off to a directive file and see what the directive is to get Roman numeral page numbers. I'm into the file now. Here's the first level of the hierarchy. Let's open up page formatting. We want page numbering, so we'll open that up. We find, yes, here it is, Roman numerals. We find out the directive. Yep, your bug's right on it already, Doug. Here's the directive we want. So we work down quite a way into a hierarchy, as you can see. This is quite a nice way to be able to very quickly find what you're after.